Today what I'm going to do is I'm going to give you 8 very important functions. For each one of these functions, I'm going to give you an equation and a graph of the function. What I want you to do is I want you to memorize these equations and these graphs. The reason for that is in the next section we're going to be manipulating these graphs, and you're going to have to know what the original graph looked like very quickly. And the further you go on in mathematics, you're going to have to know what these graphs look like. You're going to see them a lot, and you'll just have to be able to recognize them. So a good strategy for this, how to memorize them, is to make a flashcard. On one side of the flashcard you put the equation, and on the other side you put the graph. After we learn these 8 functions, we're going to talk about something called a piecewise function. And a piecewise function is a function that's defined in pieces. So let's learn our 8 very special graphs. These graphs are also called parent functions. So the functions are called parent functions. And they're called parent functions because they give rise to other functions. Here are the first 2. These you should actually be very familiar with. You have f of x is equal to some number, and f of x is equal to x. This first one is called the constant function. For example, right here I have the constant function f of x equal to 3. It's just a horizontal line. So if it was f of x is equal to negative 10, you'd put a straight line at negative 10 on the y-axis. The second function is called the identity function. It's just y is equal to x. So f of x is equal to x. Remember, usually we write y is equal to some number, but with functional notation we replace the y with f of x. So here is the graph of f of x is equal to x. The reason that it looks like this, remember that the slope of a line is the number in front of the x, which is 1. And you can see that the y-intercept is 0, so it goes through 0, 0. So you can actually plug in points, like if you plug in 1, well, you just spit out the 1, so you have the point 1, 1 on your graph. You have the point 2, 2, 3, 3, 4, 4, you have the point 4.5, 4.5 on the graph, and so on. Real quickly, let's talk about domain and range. The domain of the constant function, I'm going to write it right here. The domain is negative infinity to infinity. You can see that for every x value, we're going to have a y value on this line. And this line goes on forever in the left and right direction. The range, however, is actually one single number. And that number for this particular constant function is 3. But for any constant function where you put a different number here, the range is going to be equal to that constant. For the identity function, the domain is all real numbers, and so is the range. Again, remember, for domain is everything you can plug into the function. Here I have no fractions, I have no square roots, I don't really have to worry about anything. So I can put whatever I want into the domain, and I can get whatever I want out for the range. So you can see that for any y value, you're going to have a point on the graph. So those are the first 2. The next 2 are the square function and the cubed function. So let me zoom in a little bit right here. Let's focus on the square function. This is also called a parabola, and I've said this several times. A parabola. It's U-shaped. You can check a few points if you want to. Like if we plug in 0, we'll get 0 squared, which is 0, so we have a point at the origin. If we plug in 1, we'll get 1. And if we plug in -1, well, -1 squared is 1. And you can see if you plug in 2, you'll get 4. -2, you'll get 4. This graph is symmetric with respect to the y-axis. We could talk about the domain and the range. The domain is all real numbers. As you can see, this is going up forever, but it's always going a little bit to the right, and this piece is always going a little bit to the left. So no matter how far out you go on the x-axis on either direction, this graph is going to go up, 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 and you're always going to cross. For any x value you have, you can go up high enough, you'll find a y value. The range, however, you can see that all of our y values are up here. We don't have anything graphed below 0, so the range is from 0 to infinity. Okay, now let's look at the cube function. The cube function kind of looks like the parabola on one side, and then this part of the parabola is flipped. And it's actually a little bit skinnier than this one. You can see that this side isn't as far out as this one. So the cube function, again, let's talk about some important points. So if we plug in 0 and cube it, we get 0, which you can see I have a point right here. If I plug in 1 and I cube it, I get 1. If I plug in -1 and I cube it, I get -1. So here are 3 important points on this graph. And that's another way you can remember how the graph of the function looks like. If you get confused, you can plot some points. So plotting these points will tell you, the more points you plot, the better a sketch of the graph will be. Okay, let's talk about the domain and range and if it's symmetric. Notice it's not symmetric with respect to the y-axis, but it is symmetric with respect to the origin. So let's write that down. So symmetric with respect to the origin. And the domain and the range are both -infinity to infinity. Okay, so that's 4 graphs. Let's look at 2 more. Here I have the square root function. Just looking at the equation, remember we can tell what the domain is. Because we have a square root, we can't take square roots of negative numbers. We can put 0 or anything positive in the square root, and you can see that here. The domain is from 0 to infinity. And looking at the graph, you can see the y values, well, they start at 0. And this graph, it kind of flattens out, but if you zoom out far enough, you'll see that it's still going upwards. So this also goes to infinity. So the graph, if you were to zoom out some, you'll see it kind of does something like this. Okay, so this is the square root function. You can see it's not symmetric with respect to the y-axis or the origin. This is called the cube root function. Oh, and before I move on, let's plot a couple points here. The square root of 0 is 0, so you see we have a point at the origin. If we plug in 1, the square root of 1 is 1, so we got the point 1, 1 here. Let's plug in something we know the square root of. How about 4? If you plug in 4, the square root is 2, and you can see it goes through this point. Again, if you do happen to forget what the graph looks like, you can plot a bunch of points. That'll take some time, especially on a test. So it's really important that you memorize what these functions look like and memorize maybe 3 points that the functions go through. That way when we manipulate them later, it's easy to manipulate them because we'll have these 3 reference points. Now let's talk about the cube root function. So here, if I don't see a number, it's assumed to be a 2. That means square root. This is the cube root. So, for example, the cubic root of 8 is 2, and that's because 2 cubed is 8. That's what the cubic root means. It says, I'm looking for the number that when I cube it, I get 8. And so that number is 2. You can see that if I plug in 8, because this is my x value. So if you plug in 8, it'll return 2. So x is 8, y is 2. So there's a point on your graph. If you plug in 1, well, 1 times 1 times 1 is 1. So the cubic root of 1 is 1. So you have a point at 1, 1. And if you plug in 0, the cubic root of 0 is 0. So that's 3 points for you right there. But notice that we have a portion of the graph here that we didn't have before. We can plug in negative numbers. If we have an odd root, we can always plug in negative numbers. For example, if you plug in -1, if x is -1, then the cubic root of that is -1, which is right here, because -1 times -1 times -1 gives you -1, and the cubic root of -8 is -2. So that's 5 points that help you graph this. Okay, you can talk about the domain and range for this function. You can also say that this graph is symmetric with respect to the origin. And that the domain and the range are both -infinity to infinity. Here are the last two graphs that you're going to need to memorize. This is called the reciprocal function. Why is it called the reciprocal function? Because remember what the reciprocal is. If I want to find the reciprocal of 2, then I just put 1 over 2. And that's exactly what we're doing here. So if I plug in an x value, for example, I plug in the number 1. 1 over 1 is 1, so I have a point at 1, 1. You can see that point right here. If I plug in 2, well then my y value is going to be 1/2. So 2, you can see this is 1, here's a half, I have a point right here. If I plug in something smaller than 1, let's say you plug in 1/2 for x, so 1 over 1/2 is actually 2. So if I plug in 1/2, I get the value 2. And you can plot more points here. You can also plug in negative values, and this is going to turn out to be the same thing here, but with a negative. So if you plug in -1, you're going to get -1. If you plug in -2, you're going to get -1/2, right here. If you plug in -1/2, you'll get -2. But what about the domain here? What's the only number that I can't plug in for x? X can't be 0, right? Because I can't divide by 0. So the domain is all real numbers except 0. And the range, looking at this graph here, so you can see that the domain is all real numbers except for 0, because these lines here, they get really close to 0, but they don't cross. And the range is the same thing too. Why is it the same thing? Well, if you look at the y values, you can see as we go up, this line's going up. So we're always going to have y values up until, you see I have a y value here. But when I get to 0, this line doesn't cross 0 at all. And once I get past 0, then I have some points. You can see on the graph. So the only number we have to take out of the domain and the range is 0. These lines here, x is equal to 0, where this graph gets really close to it but doesn't touch, is called an asymptote. And this line right here, where you see the graph gets really close, but we had to take it out of the range, this line is y is equal to 0, that's also an asymptote. So it's a line that we get close to but we don't touch. Okay, and my last graph that I want you to memorize is the absolute value function. This function is V-shaped. let's plug in some points. If I put in 0, well, the absolute value of 0 is 0. If I plug in 1, well, the absolute value of 1 is 1. The absolute value of 2 is 2. The absolute value of 3 is 3. You only really need a couple of these points, but you can see as I plug in more points, I'm just getting the positive value. This is like that identity function, y is equal to x, up until this point right here for 0. But if I plug in negatives, like -1, the absolute value of -1 is 1. The absolute value of -2 is 2, and so on. So you can see that this line here is the graph of -x, but only until we get to x is equal to 0. We don't have this line going on forever here, and we don't have this part going on forever here. So it's V-shaped. You can say that it's symmetric with respect to the origin. And you can talk about the domain and the range. The domain is all real numbers. You can see that this goes on forever in this direction and this direction. So for any x value, you're going to go up high enough. You'll find that's on the graph. So the domain is all real numbers. But the range, you can see that for y values, I'm always going to have points on this graph until I get to 0. Anything below 0, there's nothing down here. So the range is from 0 to infinity. Okay, so a couple of things. On your flashcards, if you decide to make flashcards to help you memorize this, just memorize the functions and the graphs. You know how I put all this extra stuff? If you memorize the functions and the graphs, then looking at the graphs, you can get this stuff. So don't worry about memorizing, oh, this is symmetric with respect to the origin, and this one also is domain and range. There's no need for that. Just looking at the graph, if you know what the graph looks like, you can gather that information. So you don't have to memorize it, you just have to memorize the graph. And then you say, oh, well, here's the graph, I know what it is. Now, what is the domain? Well, because it looks like this, it's -infinity to infinity. And the range, oh, well, I stopped graphing here. You can just get that information, is what I'm saying. So you don't have to memorize all these pieces. I wanted to show you what they were so you can interpret them from the graph, but you really just need to memorize the graph and what equation it goes with, okay? That might be a good extra step. So once you memorize these, then maybe ask yourself these questions. What's the domain and the range? And then come back to this video and check to see if they're correct. So here are the 8 parent functions you need to memorize. Okay, we're going to move on and we're going to start talking about piecewise functions. So remember, one of the functions I want you to memorize is f of x is equal to the absolute value of x. And I said to you, look at this graph here. Half of the graph looks like the equation y is equal to x, right? Half of the graph until we get to this point where x, as long as x is greater than or equal to 0, we have the line y is equal to x. The piece that was right here, we kind of erased it. And when x is less than 0, you see this line here? I'm going to try to go over it. This line, if I continued it down, is y is equal to -x, right? Goes through the origin, the slope is -1, which is up 1 over 1, up 1 over 1. But I erased this piece. And this is true for my x values that are less than 0. So when x is greater than or equal to 0, is y is equal to x. And when x is less than 0, is y is equal to -x. This is what a piecewise function is. You can write it into 2 pieces. So we can write the absolute value function like this, or we can write it like this. F of x is equal to x if x is greater than or equal to 0, and -x if x is less than 0, meaning that I can define it in 2 pieces. And these 2 pieces, they depend on my domain. So I'm going to be the function, the identity function, when x is greater than or equal to 0, and I'm going to be the reflection of the identity function across the y-axis when x is less than 0. We're going to do more, so don't worry, but this is our first experience with a piecewise function. We have pieces that make up the graph. So this is the example I wanted to show you. Let's look at some more. Here I'm going to give you a piecewise function. Piecewise, it has two pieces here. The first thing I want to do is I kind of want to get some information from this function. Remember before when we gave you a function like f of x is equal to x squared? And then I asked you, well, what's the value at 1? All you have to do is plug in 1 and you get your value. That's what I want to do here. This is a function and it's defined on a particular domain. Here you can already see what the domain is. It says x is less than 0 and also x is greater than or equal to 0, so it's actually defined on all real numbers. What I want to do is I want to plug in some values and see if we can figure out what the function's value is on these x values. So let's start with -1. So maybe jot down this equation for this function. Okay, so if I plug in -1, what you need to ask yourself is -1 less than 0 or is it bigger than or equal to 0? Well, it's less than 0, right? -1 is less than 0. So that tells you which equation you're going to put it in. So when it's less than 0, we're going to deal with this equation. So this is going to be equal to -1 plus 3. I'm going to plug in x right here, and I get 2. So f of -1 is equal to 2. Let's go with f of 0. So f of 0, okay, I look at this piece, these two pieces. 0 is greater than or equal to 0. So I'm going to be looking at this domain here. So I look at this equation. So I plug it into this equation wherever I see an x. So that's 0, which tells me f of 0 is 0. Now let's go with 2. F of 2 is equal to, well, 2 is not less than 0. It's greater than or equal to 2. So I plug it into here. So 2 squared is 4. So f of 2 is equal to 4. These are the solutions here. That's what this question was asking. But we can also talk about the graph of this function here. Notice that these are the x values and I just gave you some y values. So you could also tell me that some points on the graph are -1, 2, 0, 0, and 2, 4. Because here are the x's and here are the y's. That's just 3 points on the graph. Now I actually want to sketch the whole graph. So I'm going to actually copy this. Before I do that, let me erase this piece here because I don't want to have to scroll back up. So let me copy this. Okay, part B says graph this function. I'm going to move this down a little bit so I don't see it, and maybe move this down so I don't see that blue. Okay, and I'm going to put that function here. So the function is x plus 3 and x squared. All right, let's start with x plus 3. That, let's say y is equal to x plus 3. What does that look like? That is a line, right? This is x to the first power. We know that the slope is 1 and the y-intercept is 3. So let's put a dot. This is 1, 2, 3. Let's put a dot here. And then let's graph this line. So x plus 3 looks like up 1 over 1, up 1 over 1. So it looks like something like that, right? And then it also goes down 1 over 1, down 1 over 1, and so on. So that's the graph. But what I'm going to do is I'm going to pay attention to the domain. So this function is the graph x plus 3, but only when x is less than 0. So look at my x-axis and find 0. Here's 0. X is less than 0 over here. So, and strictly less than 0. So where 0 starts, I'm going to erase the part of the graph that's bigger than 0. So I'm going to erase this piece here. And I'm going to erase this little dot. And I'm going to put an open dot here. And the reason for that is this function is not defined exactly at 0. This piece is not defined for equal to 0. It's only for less than 0. So when we're less than 0, then we're on this graph, okay? Let me erase all of this here. Now, let's draw x squared. I'm going to do that in green first. X squared. Now again, you're going to memorize these graphs. I already know them, but you need to memorize them. So let's draw that graph. It goes through, let's write some points that we know it goes through. It goes through these 2 points. And then it goes through 2. If we square that, we get 4. So the graph looks like something like this. Remember, we want to sketch it. Okay. So this is y is equal to x squared. But look, we're going to look at this domain here. We only care about this graph when x is greater than or equal to 0. So here's 0. Here your x is greater than or equal to it. So we're going to erase the piece of the graph that is less than, for x is less than 0, which is this piece here. And for this point, because we can equal 0, we're going to fill in this dot. You see how I made this an open dot? I'm going to fill this one in. So what I'm going to do now is I'm going to make this graph completely blue. I'm going to erase this piece. So now I have the picture of this function. So what this is saying is when x is less than 0, we're on this graph, x plus 3, and when x is bigger than or equal to 0, we're on the graph of x squared. All right, now we're ready to look at the next piece, which says find the domain and range of this function. You can find the domain just by looking at the equation, but you can also look at the graph. And let's do both so that we're able to recognize it from both. Here, this is telling you the domain. It's saying x is less than 0. We're defined. And then we're also defined when we're greater than or equal to 0. So the domain for this function is negative infinity to infinity. We don't have to take 0 out because we have it equal here. But you can also look at the graph. When you go out to negative infinity, you can see that this line is going to go down forever. So no matter what x value you have, you're going to have something on this line. Then when you're at 0, so when you get bigger, you can see you have something. Then at 0, you're here. So you're defined. And as you get bigger here, this is going to go out forever. So the further you go out here, the higher you'll be on this line. This is going to continue to go up and to the right. So the domain is all real numbers. Let's talk about the range. So the range is something that we can't get just by looking at this equation. We have to look at the graph. So if we look at the graph, remember range is the y values. So if we go way down here, you see this is going to go down forever. So we're going to go from negative infinity. If we go up, we're going to have points on this line. We're at 0, we have a point here, we have a point here, we have a point here. This looks like it might be a problem because we have an open circle, but here's a point here on the graph, so we can keep going. 4, 6. The range is all real numbers as well. Let's list any intercepts. So to find an intercept, remember there's 2 types. There's going to be x-intercepts, which means we plug in y is equal to 0. And for a y-intercept, we plug in x is equal to 0. And we can do this in the equation. Let's see. Let's start with y-intercepts because that's the easiest to find. Okay, let's look at this. Y-intercept is when we plug in x is equal to 0. So we have to see where we can plug in x is equal to 0. This says x is greater than or equal to 0. So we have to plug it into this piece because that's where it's defined for 0. So we say y is equal to x squared. So let's pay attention to this piece right here. If we plug in 0, we get 0, which tells me that we're going to have a y-intercept at 0, 0. And you can look at the graph and tell that. You can see that where we cross the y-axis is right here. Right here I have an open circle. Right here I have a filled-in circle, so it's just this piece. So that tells you the y-intercept. Now the x-intercept is a little bit trickier. What I'm going to do, well, you can see we have an x-intercept just by looking at this, and you can already tell me what it is. Now you have to be careful when looking at the graph. Your graph has to be 100% accurate. Like if you sketch this thing and you weren't being careful, you could kind of go past this number, but I know for sure that it goes through this point here because the slope is 1, and which means down 1 over 1, down 1 over 1. So here I'll go through 3, I'm going to go through -3 here. But what you would do is you would set each piece equal to 0 and then solve for x. Okay? So, because this is y, so y is equal to x plus 3 and y is equal to x squared. If I set both equal to 0, I get x is equal to -3 and x is equal to 0. So here I get the point -3, 0 and also 0, 0. I want to talk about something though. If you get an x value that is not in the domain that's required. So let's say you got that x is equal to 6. Well, if 6 is not less than 0, because that's where we're paying attention to this function, then you would have to throw it out. Here you can see that -3 is less than 0, so this is okay. And this is also okay because this function x squared, we defined it when x was greater than or equal to 0. So this is true too. So these are my two x-intercepts, and you can see here's one here and here's one here. So the origin happens to be an x-intercept and a y-intercept.